Ready? Are we ready? Okay, please join me in welcoming to the stage Jorge Arce, who is a researcher at Nethermind.
Hello, hello, hello. Okay, hello everyone, good afternoon. Thank you for joining me for the very, very last talk in the entire conference. So I'm representing Nethermind Research here. Sorry, this is upside down. And today I'm going to talk about, my name is Jorge Arce, researcher at Nethermind. And today I'm going to talk about a mechanism for decentralized maintenance of Lido's operator set with a focus on white labeling detection. So that's a lot of words. I would like to give some context before we get into the nitty-gritty of what the research is about. To give some context, this research project we're going to talk about today is a collaboration that was born between Lido and Nethermind researchers with the goal of designing a mechanism for decentralized maintenance of Lido's operator set. And to be slightly more specific here, there have been efforts by Lido to introduce community staking or permissionless staking to the protocol. You may have seen a talk by Dimitri, one of Lido's contributors, I think earlier today, on the introduction of the community staking module. And this research fits very nicely with this community staking module that currently works only via a bundling mechanism. And we are looking into more sophisticated mechanisms to increase the capital efficiency of this module and bring down the bonding requirements. So stuff like identity, reputation, and even civil resistant or white labeling resistant mechanisms via game theoretical approaches or so are part of the sort of like prongs we're using to approach this research. So this is a multi-phase research project. For phase one, we did, whoops, sorry about that. For phase one, we did a systematization of knowledge for identity and credentials. This was completed late last year. And we looked at over 100 different implementations of identity, decentralized identity and verifiable credential stuff. We selected like the 70 of those that we thought could be relevant to the problem at hand that could be integrated into a Lido permissionless staking module. We delivered something that looks like that, a big database where we indexed all of these papers. We ranked them by relevance, quality score, and gave our recommendations as to what to move forward with. I'll have a QR code later on for you to check all of these sources if you're interested. And then for phase two, which is what's going to concern us for the presentation today, white labeling resistance. This was completed in late August this year. And yeah, as we said before, this is one of the steps towards enabling Lido to onboard new operators in a permissionless manner and in a more capital efficient way. So that was phase one, as we talked about. Phase two, this is like a screenshot of the main part of the deliverable. There's a QR code there if you want to have a look. I'll also have the QR code at the very end of the talk. I'm just going to give a few seconds for people who have their cameras out. Awesome. Okay. So I've been saying white labeling this, white labeling that. Maybe I should motivate the problem as to why we care about white labeling. Let us define, very informally, white labeling as what happens when a node operator delegates their nodes to another third party to run them for them, without the protocol, in this case Lido, having any knowledge of that. And there's a few problems with this. This can lead to disproportionate control over the protocol stake by a single entity without us being aware of that or being able to prevent it or intervene. It can also weaken resistance to correlated slashing, and it can introduce single points of failure if there's a single party that is holding a bunch of stake behind the scenes. And finally, we note that it is easier to deal with this with the standard whitelist module where the majority of Lido stake is at the moment. But as we transition towards a permissionless mechanism for onboarding node operators or validators, this can become harder and harder to deal with. We can see that for Lido DAO, the goal or the attribute that operators run their own nodes, that is that there is no white labeling, is high in the priority list. Right now it looks good for Lido's current validator set. As we go permissionless, we have to be careful. Okay. And so, after some discussions between Lido contributors and Lido and Nethermind researchers, we began to think about doing research on the design of a decentralized dispute resolution mechanism for Lido that would penalize misbehaving operators. So it's hard to do this while labeling resistance in a fully decentralized fashion. Maybe a dispute resolution mechanism can be introduced such that we look at the operator set or the validator set. We identify any offenses that we would like to punish, and we do so. But in order to do this in a decentralized fashion, what building blocks are required to construct this mechanism? Well, so let me walk you through the kind of things that we looked at. We analyzed so-called arbiter protocols, and this is like an umbrella term that we're using for any kind of protocol that can be used to look at evidence that happened either off-chain or on-chain and come to a resolution as to the meaning of that evidence. So here we have prediction markets, decentralized oracles, or decentralized justice protocols. So we're looking at these, seeing which ones are good, assessing the feasibility of using them for the question we have. Then we look at a very interesting part of the research, which is mechanism design. So if we are armed with such a protocol that can provide decentralized dispute resolution, what kind of mechanism, what kind of economic incentives, what kind of bonding requirements you would have to introduce for all the parties for all rational parties participating of this game to behave as intended. And these parties are node operators, accusers, and jurors. I will define them in a few slides. And then finally, as part of the research, we also looked at evidence types against white labeling. That is, how can you, okay, you have a resolution mechanism for the evidence, but what is the evidence? How does white labeling look like on the Ethereum validator set? So that's just a bird's eye view of what the research was about. Here are the 5 tasks that we set upon to resolve in detail, and you can find more details in the deliverable. So I'm going to give you a brief overview of some of the interesting findings of these tasks, as much as time allows us in this today. And so let me start with task 2, in the interest of time, SOK on arbiter protocols. This time we looked at like 35 papers and implementations of arbiter protocols in this space. We started looking at prediction markets, which you can define as, well, essentially any mechanism or protocol where people can bet on binary outcomes of future events. So you may have seen a few of these prediction markets going around, and intuitively, given that the prices of the binary options in a prediction market allow you to interpret what is the mean belief of the traders participating of the market, and they're also backing this up with capital, you wonder, is it possible to use this as a way for people to kind of like, in a decentralized manner, resolve what is the meaning of a given piece of evidence? Unfortunately, we have found that most prediction markets require some kind of trusted party to come in at the very end of the process and give resolution to the prediction market. So like say, okay, this was the truth, this is the option that wins, this is the option that loses, despite it having been in the minority, right? So removing this trusted authority from the prediction market, it's kind of hard, and actually lets us to naturally takes us to study other kinds of arbiter protocols that we will explain next. There's also decentralized oracles, like any mechanism for bringing off-chain data on-chain, and there's a few we're familiar with. Chainlink, there's Nest, there's Yuma, so on and so forth. Normally they use different types of economic incentives to remain decentralized. And the main problem here, although this is a step in the right direction already, but there's many kinds of oracles that are not the most suited to deal with subjective interpretations of data. So they're very good at reporting a numerical value or whether an event, some kind of event, but maybe not so much the significance of that event. And this is where we would like some kind of oracle that was like more subjective to look at these kinds of things. And so we come upon these third category of arbiter protocols, decentralized justice. So just a formal definition, protocols that use blockchain technology to decentralize dispute resolution by crowdsourcing the adjudication of disputes to a worldwide pool of willing juror arbitrators. So yeah, the most intuitive way to think about this is a subjective oracle, where what is relayed to the chain is a resolution as to what's the significance of a given piece of evidence. Here, similar to the case of decentralized oracles, we leverage financial incentives for people to rule truthfully. For example, we use something that is known as Schelling point mechanisms, where you have people, you restrict people from communicating with each other, and you ask them a question. And so the natural equilibrium point that arises is, sorry, and I'm missing a very important part. And you only reward the people that vote in the majority, and you punish the people that vote in the minority. Assuming that people cannot communicate, the truth arises as sort of a natural equilibrium, although it can certainly be gamed if by some kinds of attacks, which is something to be aware of when studying these protocols. So yeah, after looking at these things, decentralized justice protocols came out on top for our study, and we analyzed a few of them. We found some very interesting ideas on how to address the different kinds of attacks that a decentralized protocol normally encounters by the Kleros protocol. It seemed to be the most mature amongst the one we studied. And we also analyzed some critiques of decentralized justice by law experts, but I'll spare you the details for now. Okay, so let's say we are armed with a correct dispute resolution mechanism, which could be either something like Kleros, or in the case that there are challenges towards the integration with such a tool, then some kind of dedicated fork of equivalent functionality. Then what we need to do next is the interesting part, where you construct a mechanism that involves these three parties that I was referring to before. You have the Lido operators, and you ask these people to post a bond, which, by the way, as we will see later or validate later, this bond is much, much smaller than the bond that you were required to post for general slashing protection. This is good because it keeps the mechanism capital efficient. There's also, and if they misbehave, if they do white labeling, you take that bond away. There's the accusers. So these are parties that will be incentivized via this game to submit a case with the appropriate evidence to the mechanism. They post a bond. They also must post a bond in order to prevent any kind of griefing mechanisms where they just submit cases without any substantiated evidence, and they just are trying to game the mechanism. So to prevent this kind of spamming, they also must submit a bond, and they stand to gain a reward if they are found to be in the right. And then there's the jurors, who will be appointed by the mechanism to arbitrate the dispute. They should be knowledgeable to understand the significance of the evidence, and they split a reward, the court fees that are taken from the losing side. Here's a brief diagram of how the whole thing can be put together. You have the validator set up here, especially for the permissionless case. You have evidence providers. These are people who are not directly appointed by anyone. This is completely permissionless. They look at the validator set. They put together a case as to whether someone is doing white labeling or not, and they submit an evidence to the dispute resolution mechanism, which would integrate with Lido contracts and leverage some juror set in order to come to a resolution. Okay, so the question as to what's the right way to economically tweak this mechanism for the economic incentives to match the game theory for a rational actor is very interesting. To give a very intuitive and quick overview of what's going on, you would compute the expected profit of someone delegating their nodes to a third party that is doing white labeling and getting those middleman fees. So you would take that expected profit. You would also consider sort of the probability of being caught as a function of time, and this is a probability distribution that becomes large, or we model it as something that becomes larger and larger as time goes by, because the more evidence you're sending out, the more you're doing this, the more likely you're of being caught. And given that probability distribution, we computed, okay, what is the expected gain for this person before they get caught? And so once you have that, and involves some nice stochastic analysis of the whole mechanism, once you have that, what is the punishment that you need to apply in order to make these people be in expectation, that is on average, in the red if they try to apply white labeling, to lose money on average if they try to do that. And so this depends on a bunch of variables. This depends on the price of ether. This depends on the mean time for detection. This depends on the probability of being detected. This depends on the probability of the court coming to a just resolution, because we cannot expect a perfect court. And put all of these factors together, we generated a simulation tool to be able to compute that crucial answer, like what would be necessary punishment to apply in order to have these people in expectation be losing money so that as rational actors they would not attempt white labeling. You can find this in the deliverable as well, the link, the QR link that I shared earlier, and I will share at the end as well. And we come to this graph, and to explain the significance of this is the minimum accuser's reward. That is the minimum reward that must be paid for a white labeling case as a function of the number of validators involved. We have a linear offset here, simply because to make a small case worth the accuser's while, you need to, well, provide some, at least a minimum amount of payment. And then you see that this scales actually, well, linearly, but the slope is pretty small, which is good. Because that means, like, for example, for 100 validators, if someone is trying to post 100 validators, for the mechanism to gain this white labeling resistance property, look at the y-axis. We have something like 5 ETH or so. So that means that with 5 Ether, or like approximately 0.05 additional ETH per validator, assuming the market conditions of a couple of months ago when the research was posted, we could adequately collateralize against the threat of white labeling. And this is, like, once again, a very small percentage of what you would need to defend yourself against slashing risks, which is much more than that, right? At least 1 ETH per validator. This is good, because the goal of achieving adequate capital efficiency, this leads some credence to the fact that this mechanism could work for that. And our deliverable also provides a bunch of other goodies, which I encourage you to check out. Economic analysis on bundling requirements and financial incentives. So kind of like the math behind those graphs and those tools that you saw. A simulation tool to update the above, like these economic analysis versus market and tech parameters. I showed a screenshot. Guidelines for a testnet phase and experiments for initialization. We want to validate these things with some kind of experimental phase that shows that our formulas are indeed whole water. A description of a fail-safe mechanism, what you would do if, like, the decentralized core just stops working from overnight. And strategies for how to achieve juror curation. That is, how to check that jurors know what they should know. Okay. And then let's talk about task 4, which I have been talking about the game theory behind making this whole thing work, but you may be interested in knowing, okay, what kind of evidence am I looking at? What kind of identifying mechanisms am I looking at to see whether someone is doing white labeling or not on Ethereum? Well, we reviewed the literature here and the known ecosystem insights on how you can gain sort of like additional information about a validator and who is running a validator behind the scenes. And this has actually been an interesting problem in the Ethereum ecosystem for a long time. To provide a couple of examples, and I'll come back to what has been known for a while, like this relates to some concerns about validator anonymity that have been known since like 2020 in the Ethereum ecosystems when like the transition to proof of stake was first proposed. But coming back to the task at hand, some ways in which you could do that, in which you could identify white labeling would be, one would be using machine learning classifiers or heuristic approaches that are trained on features of the validators related to the validator's performance. So by analyzing the sort of like metrics of validators, you could come up with unsupervised machine learning approaches to kind of like attempt to cluster those validators into their operator sets. And you can ask, like, how effective is that? Like, how much data we have to make this work? And I would direct you to some research, very interesting research by Rated. This article called Solo Stakers, the Backbone of Ethereum, shows how you would do exactly that and how they identified some clusters of whales that were, it was highly consistent that they belonged to the same person behind the scenes. And they used this to identify 6.5% of validator indices that belong with very high probability to solo stakers, but we can adapt these techniques also for the purpose of clustering directly. So that was one thing that we discussed. Another one would be, and this is related to the whole validator, to the discussions on validator privacy that have been going around in Ethereum research for a while, networking layer analysis to correlate validators with the same beacon node. So you could have a crawler on the Ethereum networking layer, and this crawler looks at how attestations are propagated on the Ethereum network to tell whether attestations belonging to different validator keys are likely to be originated from the same Ethereum node, that is from the same consensus node, which would be used as strong evidence that these validators are being connected to the same node, hence being run by the same person. With white labeling, this works really, really well, especially if someone gets sloppy and just like delegates it to a major, delegates their validator to a major node operator, because they are likely to just mix validators with validators of their own or validators of other parties. Now, and the research goes, or like the deliverable we wrote goes into some more detail on how to make this work, what are some future research directions to follow. I would also point out that this is a starting point. So long as we have the right economic incentives in the mechanism we talked about before, the game theory would lead us to believe that the right people are going to come up and start doing this for profit, right? And this is our intention with having a mechanism that allows people to, once again, make a profit by identifying the white labeling cases. Just to start wrapping it up, some future research directions beyond this phase 2, and going back to the things that we alluded to at the beginning of the talk. Civil resistance, it would be nice for us to have an economic analysis of how does a civil attack look like for our dispute resolution mechanism, and what kind of economic restrictions we need to impose to add civil resistance to the validator set. State-of-the-art approaches to achieve civil resistance in our operator set. We would like some more time to, or go more deeply into the literature and come up with some ideas for civil resistance that work here. And protecting the juror set for civil attacks is also important. Reputation systems, how can you connect these things with reputation so that you're incentivizing the correct behavior of jurors, not just with capital, but also with reputation. Reputation for the operators themselves, and how all of these things, what's the big picture of these things put together. So that would be it. Thank you very much for your time and attention today. We are Nethermind Research. If I managed to convince you to have a look at our deliverable, then here's the QR code again. Thank you very much, guys.
So if anybody has any questions, they can raise their hands. No? Okay. Well, thank you very much for coming and speaking. This is actually the last talk of the conference, so thank you very much for coming to the conference.